Hello and welcome to this issue of Motive Garage, proudly presented by Just Car Insurance. Now this is our third episode of our ERUBISU build, our VR38 powered R34 GTR that we're building in conjunction with the guys from Power Cruise. Now you saw our last issue, we had an Albans transmission being made to suit the car. That's got a fair bit of development time. We also need to get a custom twin plate clutch made, so in the meantime, we decided to install our monster brake setup, which we're certainly going to need with the amount of power we're going to be making. Let's check it out.
As we mentioned in our first episode, the goal with the car is to make well beyond 1,000 horsepower and use it for racing in the crew sessions at Power Cruise, as well as able to turn some laps. We also plan on using it for top speed runway events. This means the car needs to be able to stop, and stop well, so some monster brakes are required. We teamed up with our friends at CC Brakes in Queensland to piece together a suitable brake package. First, we had to decide what size rims we were going to use, as that would limit our brake size. With 19s decided on, we could choose our brakes. Like all CC brake kits, we received everything we needed in the kit: calipers, rotors, mounting brackets and braided lines. This makes it a bolt-on affair. You can also order the brakes in a range of different colours, making it easier to suit your car out of the box. Now let's take a closer look. For the front, 8-piston calipers with 385mm rotors. The calipers come in a few sizes, with this being the largest. The brake pads are QFM that are done to CC brake specifications. The 2-piece slotted and drilled rotors are fully floating. Serious stuff. On the back, a medium-sized 6-piston caliper with 356mm rotors. Once again, the brake pads are QFM and the rotors are a floating 2-piece drilled and slotted design. The kit comes with Loctite, bolts, washers, shims, braided lines and the adapters. A true bolt-on kit, as you can see installed here. The rear brakes work with the factory drum-style rear handbrake, so it's suitable for street cars as well as track cars. With the 19-inch Volk LE37s we are using as our track wheels fitted up, you can see the monster brakes fill them up pretty good. Now we just can't wait to get the car running so we can give the brakes a try.
Well, it's been a couple of months of development for our Albans sequential transmission, but it has arrived here at Brintec Customs and is ready to go in the car along with our custom-built twin plate clutch. Now, to give you a bit of an idea of what sort of jigsaw puzzle we're dealing with here, let's take a bit of a quick look. R35 engine and front diff. We need to get shafts that work with R34 hubs. We've got the sequential on the back with an R32 GTR transfer case, which then needs to connect to an R35 front diff. We then have to get a tail shaft made to go down the back to an R32 GTR mechanical diff, which then needs to connect out to R34 hubs, which are wider and further away than a normal 32. So it's a pretty big jigsaw puzzle, but the guys here from Brintec Customs specialise in engine conversions. So let's get this puzzle together and show you what's going to happen.
Now, if we were building a no-expense spared race car, it would be straightforward to design everything in CAD and have it all custom fabricated onto a bare shell. But it would also be very expensive and the average modifier couldn't relate to it. But this isn't a no-expense spared build, and we want the R34 to keep its street car origins by using as many factory or factory-derived parts as we can from the GTR family. It also makes it easier and cheaper to fix if something breaks. Josh from Brintec Customs has years of experience working on every model of GTR and is also handy with engine and drivetrain conversions, which Brintec specialise in. So between us, we figured we could work out the drivetrain jigsaw puzzle. Now, we already had the engine, front diff and front drive shaft sorted out, but our next big hurdle was getting the diff ratios to match. You see, the R35 GTR has a 3:7 diff ratio, while the R34 GTR has a 3:5 diff ratio. And the R32 diff we wanted to use has a 4.11 diff ratio. We searched high and low for a 3.7 rear diff ratio, but it just simply didn't exist in one suitable for a GTR. And we also thought there would be no off-the-shelf alternative diff ratios for the R35 front diff. While we were at the Albans factory, we mentioned the problem and they informed us they had already developed a 4.11 billet crown and pinion wheel for a customer. Lucky for us, they have one of the only CNC machines that can make crown and pinion wheels in the country. A massive problem already solved. The front diff is now being off-rebuilt with the new crown and pinion. The rear diff was the next problem, as we wanted to switch to 4.11 like R32s and R33s and ditch the V-Spec Active LSD and replace it with a traditional mechanical diff centre. Turns out R34s are wider, and although the diff bolts in, the R32 shafts are too small. Luckily, we found an easy way to make a hybrid shaft using R32 and R34 V-Spec items. Good old Nissan. The VR38 doesn't come with a flywheel from factory, so the guys from Direct Clutch Services in Queensland worked with the guys from Albans to develop a billet flywheel which also incorporates the factory crank position sensor. They then put together one of their new hybrid twin plate clutches for us. We've been using Direct Clutch Services twin plates in our R32 GTR and our 200SX Time Attack car for the last few years with no issues, so we knew we could trust the product. The Albans box uses a massive 32mm by 29 spline input shaft, so the clutch plates were made to match. The clutch will be operated by an internal slave cylinder setup that was developed by the guys at Albans. Albans computer designed the VR38 bell housing and attached it to their ST6 sequential gearbox with the adapter and output shaft to suit a GTR transfer case. The gearbox is rather large, and due to the placement of the VR38, some cutting of the tunnel was required. But we figured if we had to cut it out anyway, we might as well cut it out completely so we could make a new and larger tunnel section, enabling much easier serviceability. We can now raise and lower the gearbox vertically with no twisting or yelling like a normal GTR gearbox. The mount on the Albans box lined up pretty nicely with the factory crossmember holes, so Josh custom made a bracket and welded it to the factory crossmember. Pretty straightforward stuff really. With the box in and the front and rear diffs sorted, we needed to join them all up. The tail shaft is simple, an R34 rear section mated to an R33 front section that's just been custom lengthened. The front shaft was almost the correct length by total coincidence, but the R35 front diff has a different flange, so the front shaft is simply being modified to suit. And that's it, the puzzle done. Some of it seemed hard but was simple, while some of it seemed simple but was very hard. There is a couple of secrets to it all, but we got it all to fit. Now it has all been removed, so the diffs and transfer case can be freshened up and strengthened, and the custom shafts made. We then started stripping down the engine so we could make the modifications we needed. But more on that next time. Stay tuned.